Okay, great. Hi, everyone. This is actually more than I expected. My title is not good, so suggestions for an improved title would be appreciated. Yeah, because as I said earlier, the target for this talk is people who don't know what an AST is, or maybe only know a little bit. So this title is really bad. But yeah, this is some stuff about me. My name is Kent C. Dodds, and I work for PayPal. You can find my slides here at the bottom, kcd.im/beginner-asts-slides. And now I'd like everybody to please stand. If you're physically able to join us, please do so. Okay, so how many people came to my earlier talk? All right. Oh, wow. Thanks, everyone. So most of you know what this is about. This is an air squat. It's called exercise, and we're going to do this all together. We'll do 12 of these. Count out loud with me. Yeah, put both hands out. I'm holding them. Sorry. And count out loud with me. Ready, go. 1, 2, 3, 4, 5, 6, 5. Just kidding. 7, 8. You're doing so well. 9. Wait, am I the missing count? I don't know. 12. Okay. I was going to start over. All right, reach up over your head high and stretch over to one side and over to the other side. All right, before you sit down, turn to your neighbor, introduce yourself, and thank them for coming to the conference. All right, awesome. Thank you. Sorry you two missed the exercise. That's too bad. So, yeah, I like to start my talks out like that because I'm always nervous before I speak, and that loosens me up, and we're now friends because we've exercised together, and so I'll see you next year for our yearly exercise, which we only do once a year. Okay, so just kidding. We exercise regularly, healthy bodies. So I like to start my talks out with expectations, so nobody's disappointed with like the talk. So if this isn't what you expected it to be, you can feel free to leave, and I will not cry in front of you. So I'm just totally joking. You just leave, I don't care. So this is a basic introduction to the concept of ASTs. So if you write a compiler, this is probably not what you're looking for. Maybe it is, I don't know. But this is specific to JavaScript, and this is actually, I spend the first little bit talking about what ASTs are, and then a lot of it is about how to use them practically with the tools that we have today for JavaScript. Specifically, Babel and ESLint. So how many people are familiar with Babel? Okay, most of you. ESLint? Okay, also most of you. So if you're not, then that part might be a little bit confusing, but hopefully I can explain pretty quickly what the value of those tools are. And hopefully by the end of this talk, you're psyched about the potential of using ASTs to improve your life. Yep, your life and work and stuff. So I'm not going to give you a deep dive into parsing, tokenizing, lexing. This is stuff that I don't understand super duper well, and there's content out there. I have a link at the end of my slides about a talk, or that's links to a talk by James Kyle, who gave a fantastic talk about compilers. He has like the simplest compiler you could possibly have, and explains it, and it's so good. And so yeah, this is also not everything you need to know about being productive with ASTs, because that is a very big subject. In fact, I have an entire workshop, full-day workshop for front-end masters about using Babel and ESLint to make custom plugins for your code bases. So you can check that out. It was actually just released today, but it'll be announced on Monday. So front-end masters, good stuff. Okay, cool. Let's go ahead and get started. I like to start with why. Why should you care about ASTs? What is it about abstract syntax trees that makes it useful to you? So I'll explain that by talking about some of these tools. Babel, one of the main appeals of Babel is that it can transpile is this weird thing, your ES.Next code into ES.Now code. Whoa. What that means basically is you have code that is really exciting. You want to write these new features. It has totally different syntax, and it's awesome. But you need to support Internet Explorer 9 or something, and then you're a sad developer. Well, Babel has the power to transpile that code. And the way that it works is it uses ASTs. So what Babel does is it takes your code, it parses that into an AST, which we'll talk about in a little bit. And that AST is basically just this giant JavaScript object that you can manipulate however you like. And then you can take that manipulated AST and spit it back out to code again. And so Babel has these transforms that can say, oh, this is an arrow function. I'm going to turn that into a regular function. And then I'll preserve all the semantics of arrow functions. And you can use the syntax that you enjoy and ship the language that the browser supports. So there are a couple other really nice plugins for Babel, and this is kind of getting into the realm of why would you want to know how to write a plugin or use ASTs. And it's so that you can make stuff like this that is like domain specific for your application. But this plugin, it's Babel plugin Lodash. The Lodash library is enormous. It's very, very big. But it's also super useful. So you want to use it, but you don't want to ship it to your, like the entire thing to your users. And so I don't know whether you're aware of this, but you can actually import specific methods from Babel and sorry, from Lodash. And then all you get is the code for that method, which sometimes is also quite big, but it's certainly smaller than the entire library. But nobody wants to write their code like this. I much rather would prefer to import the Lodash thing from Lodash and then just use it however. And so what this Babel plugin allows you to do is you can import the Lodash thing from Lodash, and then you can use it how you like, and then the Babel plugin will transpile it into a way that just cherry picks the pieces of Lodash that you need. So, and it's actually a fairly simple plugin, which is pretty cool. And then we have this Babel plugin transform React remove prop types. And this is also really useful. If you were in my previous talk, I talked about this one quite a bit. But here we define some prop types. It's almost like runtime types for our React components. And so we say, hey, Baz should accept a prop called foo, and that should be a string. And that's really useful in development, but you don't want to send that to your users for production because that's a waste of bytes. You don't want to be doing the runtime checking in production. This is only a development feature. And if you are sending this in production, then you're allocating an object for this. You're referencing this object. You are adding a property to the Baz function. You're doing a bunch of stuff that like really has no value whatsoever. And you're also like, let's count the characters. 1, 2, no, just kidding. But you're sending characters that have no purpose in the production application. And so what this Babel plugin will do is when you build this thing for production, it just removes them. And it does this for like classes and everything as well. So that's pretty handy. And then one last example for Babel plugins. This is one that I wrote recently called Babel plugin preval. And it's pretty cool. It allows you to write a node module inside of a string. And whatever you do module.exports as is what will be replaced by this like preval tag template literal. So in this case, we say x equals preval module exports 1, and so that'll be evaluated to just be 1, because that's what was module exported. And so that's not very interesting, but this is kind of interesting. You can't run this code in the browser, but at build time, we can evaluate this, and then that gets compiled or transpiled down to an actual thing that can run in the browser. So we can read files, we can do all kinds of things. I use this for localization. So I can read the right file based off of an environment variable or something, and that happens at build time. And then I run a build for every locale. And I have separate JavaScript objects that I can just send up. So I don't have to do like asynchronously get the right language. It's all right there. It's super duper cool. And then if that is kind of annoying to you, there's also like you can import from this thing that'll be prevaled or add a preval comment at the top of the file. It's pretty cool. What you can do with Babel is mind-boggling to me, and it's really quite exciting. And this plugin right here is, I think, like 150 lines of code to enable this. And what excites me about Babel is it's an enabling technology. It allows you to do things that would be prohibitively difficult otherwise. Okay, so ES.Lint, also a fantastic tool. This allows you to not transform code necessarily, well, it sort of does, but primarily it's for analyzing your code, for taking that AST object and inspecting it, seeing what it can do. So my favorite plugin for ESLint is ESLint plugin import. And this is editor integration with ESLint. There's a command line tool and stuff. But what I'm getting right here is it's saying import no unresolved. That's an error, unable to resolve the path module get logger. And it's because I made a typo. And so normally in JavaScript, everything's runtime, you would get this error at runtime. It's like, I can't find that module. But with ESLint, that'll happen statically. It'll happen before anything runs. And so that's pretty awesome. And the way that this is accomplished is this ESLint plugin will look at the AST and it'll say, oh, you're trying to import something. Let me go check if that file actually exists. And if it doesn't, then I'll say, hey, that's a warning. It does a whole bunch of other really neat things. And here are a bunch of others. There's a React plugin, a promise plugin that'll warn if you're using promises in a way that's probably not right. A security plugin, an accessibility plugin for JSX for React. So super duper cool stuff. And finally, who thinks they're really good at regex? Okay, pretty good, or yeah, pretty good at regex. I can do a find and replace like with the best of them. I don't care how good you are at regex, you cannot do better than a Codemod with a Babel plugin. And these are a couple examples of code mods. But a code mod basically is like a Babel plugin. It transforms your code, but then you save the result to disk. So think of like, okay, the jest testing framework allows you to say it.only. Let's say they decided to change only to like simply, I don't know. So it'd be really trivial for you to write a short Babel plugin that you could use as a code mod to update your use of that API without messing up comments or anything else. You don't need to worry about that. So very cool stuff. So that's a couple of the reasons why I think this is a really important topic for developers to know. Any questions about use cases before I go on to what they are? Yeah. That's my friend Rob. We were roommates. It's been a long time. So hi, Rob. Well, okay, that's a good question. So there's a tool called JS CodeShift that works a little bit differently, but the way I'm going to show you, and the way I think is easier, is it's effectively a Babel plugin. And what Babel will do is take your code, create an AST, your Babel plugin makes some modifications to that AST, and then Babel will turn that AST back into code, and then you take that code and save it over the file that it originated from. So you'll see an example of that. Good question. Anything else? Use cases? Okay, great. So what even is this thing? Let's talk about that. So this is code for humans. It's JavaScript. I'm not sorry. And it's actually a module that's available on NPM, transformers names. So you can get random transformers names, which is kind of fun. And you can get all of the names, or you can get a random one, and you can get any number of random. But this is really nice for us. We can see unique random array. Okay, I think I can intuitively figure out what that thing's supposed to do. I know what this transformers names is. It's probably like an array of names of transformers. This get random item sounds like a function I can call to get a random item out of an array. But for the computer, it doesn't care anything about those. It doesn't care what they're called. And so what the computer sees is something more like this. This is an AST, and it is very, very big. This is the AST representation of that code that we just saw. So it's just a JavaScript object. That's all that it is. And this is why I tell people ASTs are not scary. Maybe making an AST would be scary, like doing the parsing and tokenizing, lexing, all that. I don't know how to do that. But somebody does, and they give me this AST, and I love them for it because it really, it's just a JavaScript object like anything else you're used to using. So there are lots of different parsers to create these ASTs, and the one that we used for this example is Spree. That's the one that ESLint uses. And yeah, so the computer will create an AST. I'm pretty sure that every JavaScript engine has their own parser. They do generate their own ASTs. They do their own thing. But for us, the tools that we're using, we can just use what Babel and ESLint provide for us. which is cool. So that's that JavaScript object is really big and kind of hard to read. So I'm going to give you a little demo to make it a little bit more straightforward. So we have this demo from Joint.js. This is demoing their diagramming library, and they just happen to use Esprima, which is another parser, to parse some JavaScript to demo their little charting library, which is kind of handy. I don't really care so much for their charting library necessarily, but I appreciate that they got this for us. So we have some code, and we just click this show AST, and then it will generate an AST and then generate this chart for us based off of that AST, and we can explore that. So every AST, like pretty much every AST, starts out with a program. That's the root node, and that consists of all of the contents of your program, of your file. Program has a body, and that body has these items in it. Normally the body will be represented by an array. And so these are each item in the array, that relationship there. And the first item is this variable var a equals 42. It's a variable declaration. And each one of these boxes represents a node in our AST. So there's the program node, and the variable declaration node, and then that has a variable declarator node, and then an identifier and a literal. And each piece of your code has some sort of node representation of it, and those can have relationships of a parent and child. So this variable declaration has a parent of the variable declarator node has a parent that points to the variable declaration, and the variable declaration points to the declarator. And then there are leaf nodes, like identifier and literal. Yeah, those are like really common. There's also like regex literal and string literal. But the point of this exercise here is not for you to memorize all of the node types, because there are many and they are varied, and it's only getting worse with all the stuff that TC39 people are doing. But the general idea is to understand that a tree consists of nodes. It has parent and can have children. Yeah, and it can be manipulated. So before we move on, let's go ahead and make some changes to this tree to give us a little bit more of an idea of what we can do with this. So I'm going to actually just remove all distraction here. We'll just have this variable declaration a equals 42. So now our AST is quite a bit simpler. So one thing when I started doing working with ASTs a little bit that I was confused by was I was like, why is there a variable declaration and then a declarator? And the reason for that is you can actually have multiple declarations or declarators per declaration, which is code that I don't like to write because I think it's hard to read. But some people like to do it, so we can do b equals 45. So in a single variable declaration, we have two variable declarators, and we can see that represented in our AST here. And then they each look kind of similar. Identifier on the left and a literal on the right. And so let's make this a little bit more complicated. We'll say math.pow 45 and a plus 3. Okay, so that's kind of crazy stuff, but it kind of explodes our AST, right? With everything that we add to our program, each one of those things represents a node, right? So here we have on the second item in our variable declaration, we have the b variable declarator. And variable declarators have a left and a right. The left is the identifier, the right is what it's being assigned to, or the assignment. And for our assignment, it's a call expression. That call expression actually has, the object of the call expression is a member expression, which actually consists of math on the left and pow on the right. And then this call expression also has arguments, and so on and so forth. Okay, so again, not trying to like teach you everything about this AST and have you memorize it, just the idea that as you add code, more nodes are represented by that code, or represent that code. Any questions about this? Okay, so we can actually make modifications with this tool. Like maybe I could drag this over. Whoa. Tricked ya. No, just kidding. That's confusing. Okay, so that's a nice feature. But yeah, that's not going to be very useful for our use cases. So we're going to use this incredible tool. This is another enabling technology that I just totally love. It's AST Explorer.net. And in here, we can do some pretty nifty things. So I have autofocus turned on here on the right side. And so as I click around, the right side will update to the part of the AST that I have selected on the code on the left. So I click on this function, that's a function declaration. And I can see it highlighted. As I highlight over it on the right, I see it highlighted on the left, what part of the code that is representing. So I see, oh, params, that's representing the number there. And I can click that, and I'm going to get an identifier. You'll see identifiers like all over ASTs. They're a leaf node, they're everywhere. One other thing that I failed to mention at the beginning, one thing that I love about ASTs is I learn JavaScript better, or just code in general better when I'm using ASTs. I learn what like order of operations are and what the different things are called, and so I know how to Google for those things. So if you ever see syntax that you're not familiar with, paste it in here and find out what the AST node is called, what type it is, and then you can Google for that. Because good luck Googling for ... Like, well, what does that operate? I don't know. In JavaScript, you'll probably find something now, actually. But yeah, like AST Explorer is really good for that too. Cool. And we can also look at the JSON, but let's not look at the JSON. So that's the basic idea of this tool. There's one other really cool thing. Well, actually, there are a couple other cool things. One really cool thing is that it is a general tool, not just for JavaScript, but for a bunch of other things. Are you a Scala person? You can check out the AST for Scala in this tool. Like, what? So cool. I don't know Scala, so I'm not going to demo it for you. But Markdown, this one's pretty cool. You can check out what a Markdown looks like. That's a list. Neat. So that's this tool. One other really cool thing that I want to demo for you is this transform capability. So you can select, oh, sorry, I missed one thing. Within JavaScript, like I said, there are a whole bunch of different parsers that are available. And we're looking at the Babylon 7 parser, which is the one that Babel uses. And then we can transform our code using the Babel v7 transform library. Yeah, and we'll talk about that a little bit as well. But when I click on that, it pops up this stuff on the bottom. On the left side is the transform, and we're going to write one of those, a Babel transform. And on the right side is the resulting code. So input, transform, output. And from that, what this is doing is it's taking all of our identifier nodes, and it's taking the name and reversing it. And so now I don't know how to read that word, but Semmerschnart. That's what that is. This code would not work, but this is mostly just for fun. Okay, cool. So that is that tool. Any questions so far? Okay. Anybody having fun? Yeah. All right. I'm seeing some smiles. Some people are like, "What is?" You can leave them. It's okay. Okay. So how do we use these? Let's try them out. Oh. My formatting got messed up. Screen sizes. Yeah, we're going to start with the ESLint plugin. I'm going to write one for you right here. And then we'll make a Babel plugin, and if we have time, we'll make a Codemod out of the Babel plugin. And these are practical, but the problem is that once I create this example for you, it's no longer really useful because I already created it. You just use it. So hopefully the concepts and the ideas will come out of these. And then and you can make some things that are specific to your particular domain, which is one of the things I think is exciting about this stuff. Okay, cool. So we have this handy thing. I'm using the Babel ESLint parser. I could also, I prefer using Babel ESLint just because it enables me to use even more features of JavaScript in my source code. So, but you can also use Esprit. And then the ESLint version 4 transformer. And then from this, I have in my sample code, I have the code that's valid and code that's invalid. So what we're going to write is a plugin that will warn us if we're ever using console for some weird reason. I don't know. This is an example I could think of. But like, if you use console too much, maybe it's pretty hard to like debug your Node program or your browser program. So this will disallow you to use that. Maybe you can use some other abstracted version where you can like filter out the different console messages that you have. So that would be a use case for using something like this. So when I'm writing an ESLint plugin, I often like to have the valid cases and the invalid cases all in my test file just to make sure that I'm not having false positives or false negatives. And then I start writing my plugin. So I have a couple of things pre-filled out here because it's not totally interesting. What a plugin is for ESLint is an object that has a meta property, and that has some documentation, and it can also have some options and things that we'll kind of skip over here. And then a create property, which is a function, and that accepts context. And that context object is what you use to tell ESLint, hey, there's a problem. And then ESLint will be responsible for warning the user that there's some sort of issue with their code, assuming they've enabled your rule, your ESLint plugin. And then what you return from the create function is what's called a visitor. Anybody familiar with the visitor pattern? Okay, it's not really a super common thing unless you're in this world. So the visitor pattern basically makes it possible for us to write stuff like this because nobody wants to traverse an AST. So let's talk about the problem the visitor pattern solves. If I wanted to find all of the identifiers in my program to find the ones that are called console, then I'd have to start at the root node. I'd say, okay, Babel, you gave me this AST object. It's a wonderful thing. I thank you so much. I'm going to look at the program first. That's the root of this AST I find. And I need to find or I need to look in the body. Okay, now I'm going to traverse through the body, find all of the things that are in here. And here that first one is an expression, or an expression statement. I know expression statements have expressions, and expressions have. So like over time, you're basically writing what the visitor pattern allows you to do. But you have to manually traverse this whole thing to find all the identifiers. You need to know what the properties are for everything to traverse this tree. And so what the visitor pattern allows you to do is have a more declarative API to say, hey, Babel, or ESLint, while you're doing this traversal of this AST, I want you to call my functions so I can do stuff with those things. And so you specify the things that you care about, and then ESLint will call your function when it finds those things. So specifically, what we care about is this identifier. We're going to look for identifiers with the name console. So the way that you say, hey, ESLint, I want to have the console identifiers is you, as part of your visitor object, you specify the property name as identifier, and that is going to be a method. And this method accepts a node. Who can guess what that node is? The node that it's visiting. Yes. So that's really nice. We didn't have to traverse anything ourselves. So let's go ahead and console.log this node. I always do that. Open up the console. There we go. And let's bump that up a little bit for you. So we're getting a whole bunch of console logs, maybe more than you might have expected. But it's one for every single identifier. So we're picking up foo, and then we're picking up the console from foo.console. And yeah, every identifier in the program, we're getting console log. That's cool. But we don't want to pick up foo. We want to just pick up the ones that look like these ones. So let's find out what these look like, and then we'll do a short circuit for anything that doesn't look like this. Okay, sound good? Does it? Does it sound good? I'm just joking. Okay, so it needs to have the name console, so we can actually filter out a bunch if we just do that. So we'll say const is console call, and we'll say node.name is console. And then we'll say if it's not is console call, then we'll return. This is a really common pattern that I have in all of my plugins that I see in lots of plugins, is the first thing you do is identify, is this the node that I'm looking for? And if it's not, then let's get out of here because I don't care about this node. you can move on with your traversal. And if it is, then I'll continue on with my, my function. So with that, we can actually see that we filtered that down to quite a few, but we're still going to get the console from foo.console. So we need to do several other things. And what this requires is just to look at the node that you're looking for and find the distinguishing characteristics of that node. So we can see that this identifier has a parent, and every node is going to have a parent property, which is linked to the node for that parent. And that's going to be a type member expression. Okay, so we can say let's see, and the node.parent.type is a member expression. Things are going to look better here in a little bit, but yeah, so I don't want to lose you now. You're going to end up doing a lot of ands, but I'll show you how to avoid that a little bit. So yeah, the problem is that both of these are involved in the member expression, except for this one. So we're probably filtering out that console there, which is good. So we're filtering out even more. So now we have to say also that that member expression, let's see. The member expression is the member expression dot object is our identifier. You wind up doing a whole bunch of like these checks. And so because that is really annoying to do, I have written a nice little helper called looks like. And it does what it says. It determines whether one thing looks like another, all the way down to primitive values. And it gives us one nice handy capability where if you provide a function for one of the properties, it'll call your function with that. You return true or false if it looks like that. So we'll see what that looks like here in a second. So instead of this really weird looking thing, we're going to do this. And I'm just going to like type all this out, and you can just trust me that the nodes look like this. Because I think so far you've gotten most of the value out of this little experience that you need. So we're going to say this is a console call if that node looks like this object. So the node name is going to be console, and the parent is an object that has a type of member expression, and that also has a property. So the property of the member expression, so here's the whole member expression. The object is going to be the one on the left. The property is going to be the one on the right. And so that property needs to have a name. It's going to be an identifier, and that identifier needs to be a name of a console method. So we'll say the property name is a name of one of the console methods. So we're going to go ahead and up here we'll have this variable called disallowed methods. That's an array of all the disallowed methods like log and info and warn, and we could add more like table and group end, a bunch of other things. And so now we're going to say the name. When you come across the name, if it has a name, then I want to get the value, or here we'll say arrow function. So that value, the disallowed methods includes that value. Okay, looks like, there we go. Include. Oh, includes. Yeah, includes. Thank you. Pair programming is at best, and it's val. There we go. Okay, cool. So with me so far, I think I should have done this a little bit earlier. So I'm going to take a quick break from that and show you how to report to ESLint your errors, because we can't see those console.logs without popping up the console. So I'm going to really quickly report what we have so far to ESLint, and then we'll whittle those down. So remember, your create function gets a context, and this context has some methods on it that are useful. One of them is report. And with this report, you need to specify a node. And for us, we'll just specify the node we're given. So we'll use the object shorthand right there. And a message, optionally. If you're nice, you'll provide a message. And this message will be using console is not allowed. Okay, cool. So it looks like we actually already have whittled things down quite a bit, and we could whittle things down a little bit further. Like, for example, here's something that you might consider valid, console.log. Like, I'm not actually doing anything, like making any invocation. So I could additionally add some more stuff to this looks like call to say, hey, it also has to be part of a call expression. But I think you get the idea, and I don't want to belabor that too much more, unless anybody really wants to see it. Okay? Great. Okay, and yeah, any questions about this? This is pretty much it for ESLint plugins. There's one other thing, I guess, that ESLint can do, and that is it can automatically fix your code. So if you're doing something that's not allowed or that like you don't want to do, and it wouldn't semantically change the code in any way, it's just like maybe a stylistic thing or something, then you can have ESLint automatically update the code for you, and ESLint provides an API like that in your plugin, which is handy. Yeah. Not yet. You can make it. I pretty much just copy it everywhere. The reason that I haven't made a package out of it yet is because it's just a couple lines, and I can't use packages in AST Explorer. And so that's pretty much why. Otherwise, I probably would have packaged it up. It's kind of handy, though. Like, I use it in everything now. So. Okay, cool. Let us move on to our Babel plugin. Yeah, question. Yeah, good question. It is a little bit outside of the scope, just because I'm limited on time, and yeah, I just had about 20 minutes. But I do show you how to do that in the front-end master's course if you want to go check that out. So it's not free, so sorry. But I do have a practice that I did of that on YouTube, so you go check. I'm pretty sure I should do that. I think I can't remember quite right, but come talk to me later, and I can give you resources. It's pretty well documented. Cool. All right. So that is ESLint. Here is Babel. So what we're going to do here, I'll actually, spoiler alert, don't look at the transform. Oh, I just covered up my screen. Yeah. My bad. All right. So, whoa, I didn't realize you could go that far. Now I can't get it back. Okay. So what this plugin does is it takes a console.log statement, and it adds the line number and column number where that console.log exists. So that's kind of handy, because once you uglify the code, it's going to be line number 1, column 6,582. And that's not very useful. So throwing this in there can be quite handy. You could also add like the file name from where this originated. So it would make debugging in production quite a bit easier. And you could do this with some other logging abstraction. You wouldn't have to use console log. So yeah, let's go ahead and build that. So this one is, we might not get to all of this one. I have it, one other thing that it did that I didn't mention is if it's inside of a function, it'll add the name of the function to the console log. So that'll be handy also. Okay, cool. So Babel, the API for Babel is a little bit different from the API. Where's my water? There it is. From the API from ESLint. Instead of exporting an object that has a meta and a create function and then the context return, what you export is a function that accepts Babel. This is the Babel core package. So you can go look that up. And that has some utilities that we're going to use. And then what you return from that function that accepts the Babel argument is an object that has some metadata, like the name, and then your visitor object here. And from there on out, it's pretty much, well, there's one other important difference, but it's effectively, the visitor pattern is pretty much the same. So there is one other thing about ESLint's visitor pattern that's kind of cool. Instead of just identifier, you can do like a jQuery selector type thing, like and child. Like it's kind of weird what you can do inside of the visitors for ESLint. You can look that up later. And you can't really do that with Babel. But pretty much everything about the visitor pattern is basically the same. So for our use case, last time I looked for all identifiers and then whittled that down to the identifiers that were part of a console log statement. This time I'm going to start at the call expression and whittle that down to the call expressions that are console logs. The reason I'm doing that isn't just to confuse you, it's hopefully to show you multiple ways of doing the same thing. Feedback is welcome if that's more confusing than helpful. Okay, so we're going to start out with the call expression. So if we look at this first one, we'll see that it is the whole thing that I'm interested in. I'm not just interested in this piece, I'm actually interested in the entire thing. And that's why I'm looking for the call expression. So that's what I put for my visitor. And instead of the node like we had with ESLint, we're going to get a path. And this path is an object that has access to the nodes, but it also has some helper methods that allow us to make manipulations to the AST at this place. It also has references to scope, so you can see, oh, I'm looking at this variable. Let me find all the other references to this variable that are within the scope of this function. So really, really quite powerful stuff that we have available to us. So I'm going to use this path. Here, actually, we'll go ahead and console log the path. Man, I keep doing that. There we go. And path has a whole bunch of properties on it. And if you look at the prototype, it has a whole bunch of methods. Like you can assert things, you can check whether something is like a call expression or something like that. You can replace nodes, you can append to like it's a sibling, insert sibling, or insert before or something like that. Yeah, a bunch of methods you have available on this path. Cool. So with this path, or with this path, we have access to the node, and we can make sure that that looks like the node that we're looking for. So let's do that. We'll say is console call. We'll say, and I just snuck in the looks like method in here too. Say looks like. We'll push in our path, and now we solidify like what a console call actually looks like. And then we'll say if is console call. We'll negate that. If it's not a console call, then we'll return. Okay, cool. So let's look at what a console call looks like. So it is a call expression, and it has a callee that's a member expression, and that has an object that is with the name of console. And I think that's probably good enough for us, for our purposes. We're not going to validate, the specific methods that we're using, just so long as it's a call expression that has a member expression that has the object as console. So we'll say, remember, path is an object with a bunch of helper methods. So we're going to say that this path looks like something that has a node. And then from there, we're dealing with the nodes. So we can say the node has a callee that is a type member expression. And that member expression has an object that we could say it's a type identifier, but I'm pretty sure all member expression objects are identifiers. I don't think that there is any difference. And in any case, if it's not an identifier, it's unlikely to have a name of console. So I think we're safe. But you could solidify it a little bit and say the type is also identifier if you really want to. That's why it looks like it's so nice, because it doesn't mean you have to add another and to your giant. Okay, cool. So now we should only be seeing paths that are actually the console.log paths. And then that looks right. We have 1, 2, 3, 4, and I think we have 4 in our source. 1, 2, 3, 4. So we're good. Okay, cool. So now let's start manipulating stuff. This is where things get kind of interesting and scary and awesome at the same time. So let me just reference something. I'm cheating. Sorry. Yeah, okay. So we're going to get the, for our cases, if we look at what we are actually trying to accomplish, we're trying to get the line start and like the column and the row. So on each one of these nodes, Babel gives us the location where that node exists in the code, which makes our stuff possible. It's on a LOC property. And then it has a start and an end. We're going to look at the start. We could look at the end, but that would be like right here. I think the start makes more sense. So that's going to be line and column. So this one should say 3:0. Okay, so let's go ahead and we'll get the let's say path.node dot callee dot object, and that should be our identifier dot lsc dot start. And let's console log that just to make sure we're not messed up. I normally press Option Command I to open my inspector, but if you do Option Command J, it'll open right into the console. So I'm trying to retrain my brain for that. Cool. So we have line 3, column 0, line 6, column 2. So it looks like we're in a pretty good spot. These three are indented 2 spaces, so that's why a column would be like that, which is cool. Okay, so with that, we're going to assign this to line and column. This is destructuring with ES6, one of my favorite features ever. And now we need to somehow manipulate, or actually let's first construct the string. So the prefix, we'll say const prefix equals the line colon column. Let's go ahead and console log that prefix really quick so we're not shooting blind. Okay, we got 3062, 10, 2, and 14.2. Isn't 10.2 like a code for like some police things? 10.4, something fun stuff. Okay, so now when we have the right prefix, we just need to be able to insert it into the arguments of our console.log call. So let's inspect that really quick. Inside of our call expression, whoa, okay, autofocus is messing me up. Okay, we have this call expression. It has that callee, so we validated that it's the console call. It also has arguments, and that's an array. And this is just like a normal JavaScript array that I can manipulate however I like. And in my use case, I just want to put something on the front of that array. And then when the code is spit out, then it's going to be spit out with my thing on the front of that array. But you'll notice that it's not just like a regular string that it puts in here. It's actually a node. So we have to construct a node out of our string so that it can be put into this list of arguments. And so to do that, we're going to just say path.node arguments. Sorry, that's arguments. And that is an array. It's not like the JavaScript arguments thing. It's weird. No, this is actually an array, and we're going to use the unshift method to push something to the front of this array. And we need to construct some Babel node that we can push or unshift onto this array. So the way we construct Babel nodes is using babel.types. So we're pulling types out of Babel and we're aliasing it to a const called t. That's really common for Babel plugins. Pretty much all Babel plugins I've seen aliases babel.types to t, so you can use it in your Babel plugin. So here we'll say t.string literal, and we'll do the prefix. And voila. Yay! It works. It's cool. They're all right there. Very fun stuff. And so that, that's the basic idea is manipulating an AST is just like manipulating a regular JavaScript object. You change it in some way. So immutability, who cares about that with ASTs? Mutability for the win, ASTs. That's also a source of much frustration sometimes. But, yeah, I'm trying to think if there was anything else with this that was important. I don't think so. So we could spend a little bit more time on this plugin, but I'm pretty much out of time now. By like looking for the name. So if we here, let's look at this, and I'll just show you really quick. We're at this call expression. We look up at its parent to find the closest to function declaration and get the name of that function declaration. In the case of multiply, that is a variable declaration that is assigned to, let's see, arrow function. So you'd have you have to do some fancy things, and in my solution I do actually do this. Actually, let me just show you. So here it actually inserts the function name before, and I have this function that can get that function name regardless of what type of function it is, which is kind of cool. But yeah, other than that, it's pretty much the same process of finding the node and making changes to it. There's a lot to learn about Babel, like specific APIs for manipulating things, and you can like say, hey, I want to hoist this variable to the root of the module or something like that. Lots of kind of helpers there, but for the most part, that's the basic idea, and that's as much as I wanted to get across to you. Because I don't have any more time, I'm just going to show you the Codemod just to kind of get your brains going on what's possible or use cases for Codemods. So this Codemod is taking all instances of jQuery.hide, that method, and turning it into the raw vanilla JavaScript version of that thing. Because most browsers these days support lots of the jQuery APIs. We don't need to have the jQuery overhead to do that anymore. And so this is something you wouldn't want to run like right before like every single time you build. This is kind of something, I just want my code to be like this now. And that's the idea behind a Codemod. And it's called the You Might Not Need jQuery plugin. If you can go Google that, You Might Not Need jQuery. It'll show you all the cool things that mean you don't need jQuery. It's cool. Yeah, with this one, you can actually, sometimes constructing a node is a little bit challenging. And so Babel provides this template thing, Babel template, that you can use to create this template. And then it gives you back a function that you can call and replace different pieces of that template with nodes. And then it'll construct an AST for you, which is pretty rad. I think that's awesome. And yeah, so here we're doing basically the same thing. Is it a jQuery hide call? And if it is, then we're going to find the overall path of the call, so the whole thing. That's what we're looking for. And we're going to look for the argument to the jQuery call, so that. And we're going to replace this all caps element with whatever was put inside that jQuery call. And then from there, we're just going to replace the whole path, this whole thing, with our new assignment that we created, and it will replace the whole thing. And then we save that to our code base, and poof, we now magically don't have to use jQuery for a whole bunch of stuff. So I've got another plugin like this that also does add class, and another that does show, handles show. And we can make this more robust, like what if you alias jQuery to something else, or what if you, I don't know, do all kinds of weird other things. So the point is that you can make these things pretty robust, and it's certainly better than your regex find and replace. Wrong way. Oh, wrong. I don't need to swipe. There we go. So I've got a giant list of resources. On the next slide is a link to my slides, so you don't have to write all these down. Also on the next slide is a link to a feedback link or a feedback form, and I'd really appreciate it if you fill that out. And yeah, feel free to chat with me. I love chatting, and I'll see you all around. Thank you.